For our next test, we're going to measure the response of the UPS as we transition from operating on inverter to our static bypass source and measure the overall transient response of the UPS. Now this is showing that if you had to perform a maintenance operation or anything on the UPS that requires you to transfer from inverter to your bypass path, that you know that your load will operate smoothly the whole time as we transition from the inverter source to the bypass source. So we look here on the overall UPS status screen. The input is flowing from the converter section to the inverter and output to the load. We have battery connected, and we're going to go in operating at 2.5 or 2500 amps, so 2 megawatt output load. We're going to transfer the system at full load from inverter to bypass. As you can see, the output is no longer being sourced by the inverter section, it's now being sourced by the bypass path. We're also going to capture the UPS moving from bypass back to inverter to show how the UPS responds in that event as well. So now we're going to transfer the UPS back to inverter, and we're going to demonstrate both operations on our other screen where we look at full waveform capture. Over here, showing our data acquisition system's recording of that transfer test, we can show transfer test inverter to bypass, the UPS output voltage waveform over the entire event, the UPS operating at full load with 60% of the current shown on the data acquisition system due to the placement of CTs. We can demonstrate the output current as it walks off the inverter and the output current as it walks on to the bypass. So in this event, the inverter is actually controlling the transfer, so it unloads the inverter and loads in the output bypass current source. Overall, the entire event, we have 2.89% max deviation because our utility load here at this facility, as you can see from over here, we're operating at 480 volts on the output UPS output voltage waveform, and now we're transitioning to bypass, which is operating at about 465 to 460 volts. So we have a very big drop on the output voltage due to the output voltage waveform, thus driving the max deviation. But overall, the output voltage waveform maintains a nice crisp look and feel over the entire transition with a 2.89% max deviation. Now we pulled from our data acquisition system the next test, which is the transfer test from bypass to inverter. So we were operating on our bypass source at 2 megawatts of load, and we transitioned back to inverter. So we look at the output voltage waveform here and measure the max deviation of this transfer. The inverter output current as it ramps back in to assume the load from the bypass path, which is operating on. So we were operating on bypass. This is the bypass current. We slowly unload the bypass current, and then we transition to the inverter and continue operation on inverter. As you can see with the bypass current, there is a time period after the transition where we're waiting for the output contactor to open. So we consider this a time, our lapping period, where both the output inverter contactor closes in, and then the bypass contactor opens up after the transition has been fully engaged. Overall, during this entire transient event, we show 1.1% max deviation on the output voltage waveform in transitioning from bypass to the inverter source. Again, a lot of that has to do with the output voltage waveform versus the bypass source voltage waveform. So our bypass source was 460 volts on average. Our output voltage on the UPS is exactly around 480. So by transitioning from that to here, we have about 1.11% output max deviation. We really appreciate you watching this video, and if there's any questions, feel free to reach out to us and we can provide more detailed discussion on any of the topics that you saw today.